Hello grade 11s, welcome to this lesson on using the decay formulae. To begin with, let's join Vusi and his teacher as they show us how to calculate decay.
When we worked with simple and compound interest, we used these two formulae. For simple interest or simple growth, we used the final amount A is the principal or original amount P times 1 plus the interest I times the number of years N. For compound interest or compound growth, we use the final amount is equal to the principal amount times 1 plus the interest to the power of N, the number of years. The formulae for simple and compound decay are almost the same as these. The formula for simple decay or straight line depreciation is A equals P times 1 minus I times N. And the formula for compound decay is A equals P times 1 minus I to the power of N.
So the only difference is a minus sign. That makes sense because our total value is decreasing instead of increasing. That's easy to remember. So do the letters still stand for the same things?
Well, P is the present value or principal amount. A is the final amount, N is the number of years. I is still the interest rate, but now this is a rate of decrease or the decay rate. Now let's check that these formulae work. We'll use the same car price of 80,000 Rand with a depreciation rate of 15% and see what happens in the 5th year. If the formula is right, then we'll get the same answer we found using the tables. What do you think we need to do first?
I think we should write down the formula first. But which formula must we use?
Well, we calculated the reduced value of the car for each year over 5 years, so it's on a reducing balance.
Okay, I reckon we can use the compound decay formula. P is the original value of the car, so that's 80,000. The rate of decrease is 15%. We want the value of the car after 5 years, so N is 5.
Great stuff, Lucy. If you were writing a mathematics test, you would get your first mark for just choosing the correct formula. Remember that 15% is 15 out of 100, so I equals 0.15. Now we substitute the values into the formula. We replace P with 80,000, I with 0.15, and N with 5.
How do I do that on a calculator?
Some calculators allow you to work from the beginning of the problem to the end and come to the right answer. With your calculator, we need to start with a bracket.
That's 1 minus 0.15.
Press equals to get an answer to the bracket before you raise it to the power of 5. Then to get that answer to the power of 5, press the X to the Y key and then 5.
Got that.
Again, you need to press equals before you carry on.
Okay, I see it. Now I just multiply that answer by 80,000 and then press equals. I get 35,496 rands and 42 cents. I suppose I could round that off by dropping the 42 cents.
We came to the same answer when we did this in a table.
Great. So the formula works. This calculation is much quicker using the formula.
Now let's look at a context for depreciation that does not involve money. Think about the temperature of a cup of coffee or tea. Most of us wait a few minutes after it's poured before we drink it, so we don't burn our throats. When you leave a cup of tea or coffee to stand for a few minutes, what happens to its temperature?
We did an experiment like that in science. We measured the temperature of the tea every minute for about 10 minutes, and we plotted a graph for its temperature. The graph had more or less the same shape as the compound decay graph we found for the car.
Great. So the graph showed that the temperature reduced very quickly in the first minute or so, and then reduction became less. You weren't dealing with money, so this isn't called a reducing balance, but it's still compound decay. Now let's do some calculations with this. Let's suppose the temperature of a cup of tea decreases by 6% each minute, and the decrease is being compounded. After 5 minutes, its temperature is 70 degrees Celsius. What was the original temperature?
Hey, this seems a bit complicated. Now we're using temperature, not money. Does that mean we need to use a different formula?
Well, the formulae work for any quantity we use, not just money.
I guess P is okay for the original amount, and A for the final amount is also fine. But so far, we've only worked things out for the N to be years.
Well, let's look at the formula for compound decay again. N is the number of time periods. This could be years, or we could be dealing with months, days, or minutes, or any unit of time. R is the percentage decrease in whatever time interval we're using.
That makes sense. So, in this example, A is the temperature after 5 minutes, and that is 70 degrees Celsius. P is the value we are finding, so that's the original temperature of the tea. The percentage decrease each minute is 6% or 0,06. The number of the minutes, N, is 5. Now we need to substitute the values into the formula.
Good. Let's see what we get.
But I don't know how to type this into the calculator to get P. Must I simplify the equation first?
That'll help. Start with the brackets.
That's 0,94. Then to the power of 5 gives me, 7339. Now, I can divide both sides by that to get P, right? So P equals 95,4, correct to 1 decimal place. So the original temperature was 95,4 degrees Celsius.
That is about right for the temperature of a cup of tea. Boiling water would be at about 100 degrees Celsius at sea level, and would be a bit lower if you are inland at a place that is higher than sea level. Also, the milk in the tea also cools it down a little. So we have one more interesting example of compound decay. Some animal species such as the black rhino, the African wild dog, and the Cape vulture are endangered. Also, plants like the fynbos in the Cape orchids and cycads are disappearing. This means they are all at risk of dying out altogether, of becoming extinct. The total population of an endangered species is decreasing at a rate that will result in its extinction unless something is done to change the situation. One of the most well-known endangered species is the black rhino. In 1970, there were approximately 65,000 black rhinos in Africa. That number has dwindled to less than 2,500, with the number still decreasing.
Wow, that's scary.
It is. Now let's use these numbers to work out what the yearly rate of decline of the rhino population is.
Okay, so we need to use the compound decay formula again. The final amount A is 2,500, and the original amount P is 65,000. I'm not sure what N will be though.
We'll take N to be the number of years from the year 1970 to 2007. That's 37 years.
Okay, and we're looking for the I value. So the equation will be 2,500 equals 65,000 times 1 minus I to the power of 37. I always get stuck at this point.
That's okay. We need to try and get I on its own because that's the unknown value. So the first thing to do is divide both sides by 65,000.
Okay, and that simplifies to 0,038. Equals the whole bit in the brackets, still with the power of 37. But I'm not sure how to deal with the 37. Can I divide both sides by 37?
Careful.
No, I can't. The bracket is raised to the power of 37, not multiplied by 37.
Well done, you spotted the problem. What we need to do is take the 37th root of both sides. Taking the 37th root of both sides cancels the power of 37 on the right-hand side. That's not difficult with a calculator.
I can do that. 0,038 inverse x to the y 37 is 0,9154.
That's it. Now remember, this value is for 1 minus I, so we just need to make I the subject.
Oh yes. So I'll get I equal to 1 minus 0,9154. That's 0,0846.
Well done. So this is the rate of decline of the black rhino per year. It would make more sense to write it as a percentage.
Okay. 0,0846 is about 8,46% per year.
So the black rhino population is declining by 8,46% per year.
That isn't such a lot, is it?
Doesn't seem to be too high, but look at it this way. We started with 65,000 rhinos. We only have 2,500 left. So we've lost 62,500 rhinos over the last 37 years. If we work that out as a percentage, that's more than 96% of the original number of rhinos.
The rhinos are disappearing at quite a fast rate. It's good to see how the formulae for simple and compound decay can be helpful for both financial and other real-life problems. Let's do a few examples together to get more practice. A movie theatre bought a high-value surround sound system for one of their new cinemas. The system cost 200,000 Rand new. Calculate the value of the surround sound system after 5 years if it depreciates by 10% per annum on a simple decay scale. Let's look at the formula for simple decay again. A is equal to P annum brackets 1 minus I times by N, where A is the depreciated value, P is the original value, I is the rate of decay, and N is the time measured in years. So P is equal to 200,000, I is equal to 0,10, and N is equal to 5. A is equal to 200,000 times close brackets 1 minus 0,10 times by 5, close brackets. Using a calculator, we find that the value of A is 100,000. This means that after 5 years, the surround sound system is worth 100,000 Rand. Now let's use the same formula to calculate the original value of an item that has already depreciated. Calculate the original price of a computer if its depreciated value after 7 years is 900 Rand. The rate of simple decay is 12% per annum. A is equal to 900, N is equal to 7 years, I is equal to 0,12. 900 is equal to P, open brackets, 1 minus 0,12 times 7, close brackets. The inside of the brackets equals 0,16, which means P is equal to 900 divided by 0,16. P equals 5,625. This means that the original amount paid for the computer was 5,625 Rand. Let's do one more example. This time, we'll look at compound decay. Why don't you try this one on your own first? Susan wants to sell her car in 6 years' time. The car's current value is 75,000 Rand, and the rate of depreciation is 14% compounded per annum. Calculate the depreciated value of the car. Let's look at the formula for compound decay again. A is equal to P and in brackets 1 minus I close brackets to the power of N, where A is the depreciated value, P is the original value, I is the rate of decay, and N is the time measured in years. Now to work out the answer. P is equal to 75,000 Rand, I is 0,14, and N is equal to 6 years. A is equal to 75,000, open brackets, 1 minus 0,14, close brackets, to the power of 6. Using a calculator, we found that the value of A is 30,342,54264. This means that after 6 years, the car will be worth 30,342 Rand and 54 cents. Now that we know how to calculate the depreciated value of an item using compound decay, we can use the same formula to calculate an item's original value. Let's have a look. Calculate the original price of a bicycle if its depreciated value after 5 years is 1,200 Rand. The rate of compound decay is 13% per annum. A is equal to 1,200 Rand, I is 0,13, and N is equal to 5 years. 1,200 is equal to P, open brackets, 1 minus 0,13, close brackets, to the power of 5. 1,200 divided by, open brackets, 1 minus 0,13, close brackets, to the power of 5 equals to P. Using a calculator, we find that P is equal to 2,407,603594. The original value of the bicycle was 2,407 Rand and 60 cents. Thank you for joining us. Practice what you have learned by doing the questions in the Finance, Growth and Decay task video. You'll also be able to learn more about finance on our website, www.mindset.co.za/learn. If you know the value of the ting, you'll be okay with DK. Goodbye.